Okay, so
oh, we're about to print, right?
no, so this is just putting it in a default position so it knows where everything is.
Okay, so the base is moving right now. So the base is going to come up, right, towards the
Yeah.
print head.
Okay. So first it sends the data, and then it spends a bit of time heating up the base. That'll take about 4 minutes to do it.
4 minutes to heat up the base.
No, 4 minutes to do the whole thing.
Okay.
I'm not sure how well it will stick because I'm not going to do the glue or anything because it's a small piece.
That's fine.
And we'll just see whether it works or not.
Let me get you in the video, John. So everybody knows that this is your printer. Yeah, raspberry. I've got one of these.
We've got some things. So we have an Arduino.
Yeah, I've got one of these too. Got two of them actually.
Got
a lot of fun.
Board that I also haven't done very much with.
A Beagle board.
Yeah, so this is a slightly old one actually, but they're kind of like, I suppose they are what the Raspberry Pi was before the Raspberry Pi.
Okay.
So it's like a mobile phone.
Yeah.
So it's got an ARM and graphics processing and stuff like that. Oh, it sounds like heating up. I've got a thing for programming PICs, which are very cheap microcontrollers.
Oh, okay.
This, which is a like a do-it-yourself Microsoft Touch Surface.
Really?
So what you do is you shine infrared lights. So you have those LEDs.
Right. These are the LEDs here, right?
Yeah.
Okay.
And if you shine those into a piece of perspex like this.
Yeah.
And then you put a modified webcam.
Modified? What exactly have you modified?
So regular. This isn't me. This is Patrick's been doing this. But if you open up one of these webcams, you can take out. They have a filter in them to prevent infrared light getting in.
Yeah.
So if you remove that, and instead you put some negative film, it will do the opposite. So it will only let infrared light through, and then it will behave just like a black and white webcam, except showing infrared light.
Okay.
So if you point that underneath the perspex, wherever you press on the perspex will glow.
Hold on a second. Sorry.
Yeah, no worries.
Interruption.
There you go.
Wow, look at that. Amazing.
So that's it building the raft first, which it does with quite thick bits.
Yeah.
And then it has a very fine sort of raster pattern.
What's the resolution on this?
I think it's 0.2 millimeters. But it's very good. And the thing is, it's not totally uniform. So I printed a sort of Thai statue.
Right.
Shrunk down. Some details were incredibly high quality, like there were toenails.
Right.
That were very, very small. But it sort of depends on whether the detail is sort of planar or horizontal.
Yeah.
And it's got slightly different resolution in the different directions. But actually, if you print a piece, printing it a sensible way or printing it on its side produces almost the same quality. So
right.
It's actually very precise. Whenever you have overhangs, it constructs extra plastic that you can just peel off that supports the overhanging sections.
Oh, I see.
So you can print any shape you like as long as you can pull out the overhanging bits. So this has still got some of the support material in the middle of it that I haven't managed to pull out yet. But all of this contains support material because it would be covered
Right.
And it'll be like tubes inside it.
How quickly does it harden?
Very fast. So by the time the print run is done, you can pretty much peel it off the surface. So I have a few things for being able to make, mock-up designs and play with things and stuff like that. So if you see this CNC machine, it's almost a Lego design. It's like more expensive adult Lego, if you like.
Sure.
So and that's how I guess some of the, because I'm just learning about the mechanical engineering side of things, but a lot of things, especially DIY kit things like this, they're basically made out of standardized components that are a little bit like Lego, and so if you can make it out of Lego, then you can probably print it or CNC machine it. It's a good way to come up with ideas and things. And then I've got a few other things that are like halfway between Lego and those models. So I've got this stuff, which is called Maker Beam, which is the small version.
Maker Beam?
Yeah, it's like the small version of the extruded aluminium that's used to make the CNC machine.
Yeah.
And so it sort of is a bit like Lego, I suppose, in the same way, but you can make very rigid frames for things. So one thing that I might look at doing is, if I want to attach alternative devices to this, then this might be a good way to sort of attach the pieces or build the structure.
Okay.
And we've also been thinking about things like, doing some 3D scanning maybe and stuff like that. And one thing that I'd quite like to do...
3D scanning?
Yeah.
So you can take a scan and then print it out or something?
Yeah, you probably need an intermediate stage where you cleaned it up on a computer.
Okay.
That kind of thing, so you got a complete pipeline of things.
Wow.
And the other thing, partly for research as well, is a thing called a light field scanner, where you make like a dome with lots of webcams and lights, and you cycle the lights so you can see an object and you can see all the ways in which it reacts to light and how it can be viewed from different angles. So things like this and the 3D printer work together to be able to make that kind of thing, or at least that's the plan.
So this is done right now, right?
Yeah, that's it.
Oh,
you see,
a web.
You see.
What happened?
So this is what happens when it's not stuck down. So I was
it moved.
Yeah, so I was hoping that I wouldn't have to glue it because it was small enough.
That's okay.
So you can see it was working all the way up until the point where it became unstuck.
Oh, I see.
Okay. So the way to fix that is, when the raft is put down, gluing around the edges keeps it in place. But I thought it might have worked without doing that.
That's fine.
But it didn't.
We got the idea.
You get the full sense.
Yeah.
Of the things that work and the things that don't.
But this is really nice. I mean, I didn't expect it to print such a nice figure.
Yeah. No, I really like that. So yeah, it's...
So John, tell me, why are you doing this?
Why am I doing this? I guess sometimes you just get a sense that there's something that you don't know, and you want to become comfortable with it.
Yeah.
So I've done a lot of programming, and I got interested in programming because I saw things like computer games and I wanted to know how they work.
Right.
And I don't know, maybe it's because I'm getting a bit older now. Now I'm interested in physical things. I want to understand how machines work and things like that. And I'm also really interested in the idea of automation.
Yeah.
So now that I'm comfortable making things and making a computer do things, I want to try to expand that to make things in the real world. And have, it's an amazing thought, with an experience from games, you can make a sort of virtual world, and that's very appealing. But if you can turn those virtual objects into real things, then there's something really magical about that.